Packages. Packages are containers used to group related classes, interfaces, and subpackages. Dot notation is used to identify package members in a package hierarchy. Now let's look at an example. In order to create a package, I use the package keyword followed by the package name. And remember that this should be the first statement in the source file. Here package mypackage.mysubpackage is the subpackage name. My package is the outer package name, as you see here in this picture. And then you may create a class or a subpackage or a child class or an interface inside a package. Now let's look at a couple of examples. Now let's work on an example to understand how to create and use packages. Now here I have an empty directory package demo. Now let me create a Java program here. As discussed, the first statement in the source file needs to be the package name. And here I may write a class or an interface. Here for an example I am writing a simple class. Here I am printing a message hello from my first package. Now let's compile this program. Now once I compile this program, the Java compiler automatically creates me a directory on the name of the package. Here is the directory mypack, same as the package name. Now let's see where is the class file. The class file is saved automatically inside the package directory. I have moved to the package directory. Here is the class file. Now how do I execute this? In order to execute this, I can say Java package name dot class name. Here is the message hello from my first package. In order to access a member of a package, you need to use the package name dot. I would suggest you to work on Java Virtual Guru packages section of examples to have a better understanding. Access modifiers. Access modifiers play a key role in Java programming. Access modifiers control what information is accessible to other classes. These modifiers help a class to define a contract so that the using classes know exactly what services are offered by a class. We have 4 different types of access modifiers in Java. public, private, default, and protected. We'll soon see them all in action. Public modifier. A member, variable, or method. With this access modifier can be accessed by any class. Public modifiers can be accessed within the same class. They can also be accessed within the same package. Another class in another package. And they can also be accessed from subclasses in another package. Here I have 4 classes and 2 packages. Class A has a public method aMethod, which can be accessed from class B, which is in the same package, as you see here in this diagram. The method can be accessed by class C from package 2. As discussed, public members can be accessed from other packages. And then the method aMethod can also be accessed from the child class, class aChild. This implies that public members can be accessed from any class. Soon we will see some examples on this. Now let's look at the code. Here I have the class A, which belongs to package 1, and it has a public void aMethod. And then I have class B, which also belongs to the package 1 and accessing the aMethod. In order to access aMethod, it creates an object of class A, as you see here, class A is equal to new class A, and then a.aMethod. Further, I have class C, which also has an access aMethod method, and the process of accessing this method is still the same. And then I have a child class which belongs to package 2, and here it imports package 1.class A and then extends class A. Now the only difference that you have noted is that one needs to create an object of a given class in order to access its public methods if they are not derived or child classes. However, if a class is a derived or a child class, it need not create an object, whereas it can directly access the parent class method. As you see here, I do not create an object unlike the other 2 classes. We directly call the method aMethod. So this concludes that a public member can be accessed from both within the package as well as from outside the package, and also available for the subclasses. The difference being that in a subclass, one need not create an object in order to access the parent class public members.
Hi, I'm public class Scrooge McDuck. I have a big house. Anyone can stay in my house. My method stay in house is public to all. Anyone can access it.
Hi, I'm Baby Girl. I'm Scrooge's daughter. Of course, Mr. Scrooge will let me stay in the house. I'm a child class of class Scrooge McDuck. Right, Mr. Scrooge?
Yeah, dear, you can stay.
Thank you.
Hi, Scrooge. I'm from class Donald Duck. I belong to your same package duck. Can I also stay with you in your house? And what about me, Scrooge? I'm from Mickey Mouse class in another package mouse. Can I also stay with you, Scrooge?
Yeah, you all can stay in my public method stay in house. It's accessible to all. You all are cordially invited. Mickey, even though you belong to a different package, you can access my public method. Come, I'm waiting for you all.
Private modifier. A member with private access modifier can be accessed from the same class, but cannot be accessed from any class in the same package. Neither can be accessed from a subclass in the same package. Neither can they be accessed from a class from other package and nor from a subclass from another package. Now let's look at the code. Here I have taken the previous example and modified the public modifier to a private modifier, which means that now the A method has a private access modifier. Here I have also included another method inside the same class, class A. Now let's compile this code. The code compiles. This goes to say that a private member can be accessed within the same class. Now let's try accessing the private method A method from the different classes. Here is my class B, which is private in class A. Now let's compile class B. This gives me an error which says has private access in package 1.class A, which goes to say that private members of a given class are not accessible outside the class. Now let's try to access the A method from class A in a different package. Here I have package 2, and I have class C, which has a method access A method, which is also trying to create an object of class A and then access A method. Now let's compile class C and look at the outcome. This also gives me the same error. Now let's see if we can access a private member from a child class. Here is a child class, class A child, which extends class A. It also has a method access A method where it's trying to call A method. Now let's compile class A child. This also gives the same error. By looking at this, I can conclude saying that a private member can only be accessed from the same class.
Though everybody can stay in my house, nobody can access my money. I love my money. My money is a private method.
But Mr. Scrooge is my parent class. Maybe I can access his private methods? Can I access your my money, Mr. Scrooge? I'm so out of cash these days.
Not at all. My money is my money. Nobody can dare to have it. Not even my child can have it.
Hey, hi Scrooge. I'm your friend Donald Duck from your own package Duck. Can I access our money? We are friends, buddy. Hey Scrooge, my dear friend, when I can access your house, why not your money, buddy? Though I'm from different package mouse, still let me have some share of your money.
No. Not you, Donald, of same package. Not even you, Mickey. You belong to a different package. My money is private. Only I can access it. None of you dare touch my money.
Oh.
Protected modifier. A member with protected access modifier can be accessed from the same class, another class in the same package, subclass in the same package, subclass in another package, but cannot be accessed by another class in another package, which is not a subclass. In this example, I have changed the access modifier of A method to protected. Now let's see how does it work. Here I am compiling class A. It compiles successfully. This implies that accept a method is able to access a method directly from the same class, which implies that protected members can be accessed within the same class. Here is my class B. Class B belongs to the same package. Now let's see if class B is able to access the protected member of class A. Here we go. Class B is able to access the protected member. This implies that protected members can be accessed within the same package. Now let's see what happens when we go to a different package. Here is a class A child, which extends class A. Class A child belongs to package 2, a different package. Let's see if A method is accessible in class A child. Yes, the program compiled successfully. This implies that the child class of a different package can still access the protected members. Now what about non-inherited classes from a different package? Now here is class C belongs to package 2, a different package, and trying to access the protected member A method. Here is the error. A protected member cannot be accessed from a different package.
Hey, this is my grandpa's watch. It can only be accessed by people of my package. Only ducks can access my protected variable watch. Well, I love my dear child Wabby too. Since she is my child class, even she can access my watch. I don't mind even if she is in another package.
Hi Scrooge, I'm here again, friend. From your own package duck. Can I access your watch? It really looks good.
Yeah, Donald, you can access my watch. You are from the same package duck.
Hey, thanks, Scrooge. Hey, Scrooge, can I access your watch? I get late every day to meet Minnie.
No, Mickey, sorry. You are a mouse. Neither of my package nor my child. You can't access my watch.
Oh my God.
What about me, my dear Mr. Scrooge? Can I take your watch? It's so nice.
Here, my dear child, take my watch. You are my subclass even though you are in another package.
Thank you so much. You're so nice.
Default modifier. A member with default access modifier can be accessed from the same class, another class in the same package, a subclass in the same package, but cannot be accessed by a subclass in another package and also a non-subclass from another package. Here is a class with a default member A method. Let's check if a default member can be accessed within the same class. It compiles successfully. This implies that a default member can be accessed within the same class. As you see here, access a method is calling a method. Now let's check if a different class in the same package can access the default members. Here is class B in the same package, package 1, accessing the member of class A. It's possible. It goes to say that default members are available within the same package. What about a different package non-subclass? Here is class C trying to access a method of class A. Here is the error. It says is not public package 1.class A cannot be accessed from outside package. This goes to say default members cannot be accessed from a different package. Then what about a different package subclass? Here is class A child extending class A, trying to access the method A method. It's the same error again. This implies that even subclasses from a different package cannot access default members. Access modifier summary. Here we have 4 access modifiers: private, default, that is no modifier, protected, and public. Now let's look at their accessibility. Private. Private members are accessible within the same class. Further, private members are not accessible in any other class or any other package, as you see here in this table. No modifier or default. They are accessible within the same package, irrespective of whether a class is a subclass or a normal class. Default members are not accessible from different packages, neither for the subclasses. Protected members, in addition to the default access modifier, are also available for different package subclass. However, protected members are not accessible for different package non-subclasses. That is, protected members are same as default members, but in addition they are accessible from different package subclasses. Public access modifier. As discussed, public access modifiers or public members are accessible throughout the application, irrespective of whether it is a subclass or is from a different package or from the same package. I would suggest you to work on the examples of Java Virtual Guru to have a better understanding of these access modifiers. Other modifiers. Final. Final features cannot be changed. The final modifier applies to classes, methods, and variables. It applies to classes when I do not want to subclass a given class. It applies to methods when I do not want a given method to be overridden, or when I declare a variable to be constant. Abstract can be applied to classes and methods. Abstract is opposite of final. Final cannot be subclassed, whereas abstract must be subclassed. We have already seen a session on final and abstract members. Static modifier can be applied to nested classes, methods, variables, free-floating code blocks, also called as static blocks. We have already seen an implementation of static modifiers or static members. Static variables are initialized at class load time. A class has only one copy of these variables. Static methods can access only static variables. Native can be applied to methods only, including static methods. Written in non-Java languages such as C, compiled for a single machine target type. However, in this course, we would not be getting into detail of native implementations. Transient can be applied to class level variables only. Transient variables may not be final or static. Transient members are not stored as a part of object's persistent state, that is, not written out during serialization. Serialization is a part of persistency. However, I will take you through an example of transient in Unit 7 while we deal with Java IOs. Synchronized can be applied to methods or parts of methods only. Used to control access to critical code in multi-threaded programs. We will look at an example of synchronized modifier during our sessions in multi-threading. That is for Unit 5. Volatile can be applied to variables only. Can be applied to static and final variables. Declaring a variable volatile indicates that it might be modified asynchronously, so that all threads will get the correct value of the variable. I shall take you through the volatile variables when I deal with Java IOs, that is in Unit 7. Volatile variables are opposite to transient variables.